Today we're going to be talking about Isosceles angle theorem, Isosceles triangle theorem, same thing. This one's more simpler than the other ones that we've covered, but you guys will need this in the future. Here are the notes for it. It basically tells us that if we're given an isosceles triangle, we know that if two sides of the triangle are congruent, then the opposite angles are also congruent, meaning they're the same. So if the sides are congruent, their opposite angles must be congruent. And if you guys can see from the picture to the right, that's exactly what we get here. We're given our sides are the same, therefore the sides and the angles must also be the same as well. Okay, we can apply this to only an isosceles triangle, and if we're just given a triangle, if it has two same sides, it's an isosceles triangle. Or if the angles are the same, then it is also an isosceles triangle. Okay, take your time, copy that if you need to. Now, one thing that we're going to be able to see here is we're given two different types of problems. One, we're given the angles that are equal. The other one, we're given the sides that are equal. For problem number one, we just got to be able to identify that. We're given angle 40 and angle 40 are the same. Since two angles are the same, it is an isosceles triangle. Therefore, we know that the sides must also be the same. Same means equal. So what we want to be able to do is we're going to go ahead and set them equal to each other. 3x minus 5 is equal to x plus 21. Okay, so this is just like solving out. I'm going to move over my values to the left, my variable to the left, so minus x to both sides. I'm going to be given 2x minus 5. Our x's are going to cancel, and we're going to be given 21. I'm going to add 5 to both sides. I'm going to be given 2x is equal to 26. We're going to divide out both sides by 2, and x will be equal to 13. Now, if I wanted to find out what one of the sides is, I could actually do that. Okay, what I would want to do is I'm going to take my variable here, and I would actually take it and plug it back in to either side. Either side, they should be the same. And we're going to go ahead and check that. So the first one, we're going to get 3 times 13 minus 5. This will give me 39 minus 5. This will give me 34. So I know that one length is 34. If I do it to the other one, I'm going to get 13 plus 21. If I do these two, combine like terms or add like values, I'm going to get 34 as well. Okay, so I know that I did my equations right and it worked out. Okay, the next one to the right is very, very similar. We're given an isosceles triangle, and I know that because the two lines on the side tell me that they're indicators. The indicators tell me that they're also an isosceles triangle. So if I know that the isosceles triangle are the same, I know that the angles must also be the same. So I'm going to go ahead and set these two equal to each other. We're going to get 2x minus 25 is equal to x plus 5. I'm going to subtract out x to both sides. This one's kind of more simpler than the other ones. We're going to get x minus 25 is equal to 5. I'm going to add 25 to both sides. We're going to get 25 and 25 are going to cancel. I'm going to get x is equal to 30. Okay. Again, this is a variable. If we want to solve out, all we have to do is plug back in. I'm going to go ahead and do that one last time and take this value and plug it into the one on the right. We're going to get 30 plus 5. We know that's in degrees. 30 and 5 is 35 degrees. Okay. Look at these problems, review them, and we'll cover more tomorrow. Have a good day.